Hello, this is Mr. Gilmore with the 7.1 Ratios and Proportions lesson. Now, in this chapter, we're going to encounter a number of different theorems that actually involve this word proportion. So today we're looking at what is a ratio and what is a proportion and begin to expand upon what are ways that we can actually manipulate our proportions. Let's start with what a ratio is. A ratio is a comparison of two quantities by division. In other words, it's like a fraction. We can write two numbers in fraction form. That means what we really have is a ratio. So down below we have an example of this ratio, 23 over 29. However, we can write it in another form. We can use the colon to separate our two quantities. So 31 colon 37 is another way that we can actually write out ratios. Now, ratios lead us into proportions because a proportion is an equation of ratios. Essentially, you bring two ratios together and set them equal. We have A over B, C over D as two individual ratios. Put an equal sign between them. You've got yourself called something called a proportion. Now, a proportion can actually be written in colon form as well. You may not have seen this form. In colon form, we use a single colon to separate the two quantities, but we use a double colon to separate the two ratios. So it's A colon B double colon C colon D. Now, we don't read it like that. We don't actually read the colon. We read it like this. A is to B as C is to D, which is really the same as fraction form A over B equals C over D. Okay, so either way, you actually will see these two forms used in this lesson and on the worksheet. They will be written in the colon form and in fraction form, and you can interchange the forms. The one thing about colon form is easier to write it all in a linear statement, whereas with the fraction form, you are required to have the fraction function to actually get those in fraction form. Now, a lot of times, let me explain a mistake that students will make. A lot of times, students will bring two things together and say, oh, look, these things are proportional, but we got to be very careful with that. A proportion is actually four things, right? There were four quantities that go into proportion. Each of the two ratios had two quantities, making that four quantities. So when we bring four quantities together, it's possible for us to say that, yes, things are proportional. But when you only bring two things together, like two quantities, you're not allowed to say they're proportional. You can say that there's a ratio of them, yes, but be careful. You need to resist saying that two things are proportional. You have to really be saying that four things are proportional. Now, proportions are broken up into two categories. We give these two categories names. We call them the means and the extremes. Now, the means are the two numbers on the interior of a proportion. That means B and C are called the means. And it's really easy to see when we talk about this in the colon form that B and C are in the middle, which means those are the means. They're in the middle of our proportion. Now, the two values on the outside, A and B, we call those the extremes. Okay, so the ones on the very ends of our proportion are called the extremes. Now, there's something special that will happen with these means and extremes. We'll talk about what those are. And you can also see means and extremes in fractional form of a proportion. It's just a little harder to actually see in fraction form. Let's just take a look at what our means and extremes are in fraction form. So in the fraction form, the means and the extremes are still there. B and C are still the means, and A and D are the extremes. It's harder to tell what is in the middle and what's on the end. It's easier to see that in colon form, and that's actually in colon form where we get those two names, the means and the extremes. But we can also see them and visualize them here in fraction form. So what this is leading us into is something that you guys have learned way back in algebra called cross multiplication or cross products. In other words, we can use this to solve a proportion. So what we can do is we can bring a proportion together, A over B and C over D. And if this is a true proportion, meaning that the two ratios are in fact equal to each other, then what we're really saying is that the product of the means is equal to the product of the extremes. So multiply the two mean numbers together, B and C, multiply the two extreme numbers together, A and D, and those products will be the same. You better know this as cross multiplication, where you're doing A times D and B times C. Those two products will be equal if in fact this is a true proportion. And we can use that to algebraically solve a proportion. So here's an example of where we can actually then find a missing value of x for this proportion using this cross multiplication. So what we're going to do is we're going to take our means and extremes and find the products. Let's start with our extremes. So our extremes would be x minus 3 times 17. Now be careful, 17 is going to distribute. So 17 times x, I get 17x. 17 times 3, that would be minus 51. because I'm doing the distributive property there with 17. Now I do 13 times 4. I'm going to do the product of my means as well. So 13 times 4x is 52x. And what we can do is then solve for x. So I'm going to actually subtract 17 on both sides. So I end up with negative 51 is equal to, that would be 35x. And then I'm going to divide both sides by 35. Now, a lot of you guys might be reaching for a calculator. Resist. Do not touch your calculator. This is a perfectly acceptable answer. Negative 51 over 35. What you're going to do for me on this worksheet is you're not going to give me any decimals. You're going to present your answer in fractions only, or simplified radical forms. That's why we practice simplifying radicals as well. So there we have it. That x value, when we plug it back in, is going to make that proportion true. And so we know it will be true because the product of the means and the product of extremes will in fact be equal to each other. Let's do another one. Now, this case, it's in the colon form, which a lot of you guys are going to go, oh man, which ones do I multiply? Well, it's pretty simple. Remember, the two that are on the inside are the means, and the two that are on the outside are the extremes. So I'm going to multiply the insides together and the outsides together. That's going to give me my two products. So let's do our outsides together. X times x minus 1. X times x minus 1 are going to distribute, so x times x is x squared. X times minus 1 is negative x. And then I get that equal to 2 times 1, which is 2. What we're going to do then is this is a quadratic. Think back to your algebra days. We're going to solve this either using factoring or the quadratic formula. Either way, I'm going to set this equal to 0. In this case, we can factor this. Okay, the way this works factoring is I'm thinking of two numbers that multiply to give me negative 2, but add together to give me negative 1. Well, that's very simple. That would just simply be negative 2 and positive 1. Negative 2 times positive 1 is negative 2, and negative 1 plus negative 1, or sorry, negative 2 plus 1 is negative 1. And what we can then do is take each of our factors and set them equal to 0. X minus 2 equals 0, x plus 1 equals 0, and then solve for that x. I'm going to add 2 on both sides. I get x equals 2. This is my first answer. And then subtract 1, I get x equals negative 1. This is my second answer. And so there we have it. I have two solutions to that, right? Both of them actually will satisfy the proportion. However, if the colon form bothered you, you could take this and you can re-express it into fraction form. So if you wanted to write it as this, x over 2, that's the first ratio, equals 1 over x minus 1. That's our second ratio. So either way, you're still going to do the product of the means times the product of the extremes and set them equal to each other. Now, how can we actually verify the proportion actually is true? What that means is, okay, so you brought these two ratios together, set them equal. Are they really equal to each other, though? Well, there's a way that we can test this, okay? The way we test this is we find the product of the means and we find the product of the extremes, and if they are equal to each other, then we know the proportion is true. This is the converse of what we just talked about, okay? And what we talked about was if the proportion was true, then we can cross multiply and we know the products are going to be equal. But to verify proportion, we need to know that the products are equal first, and then we can say that the proportion is true. In other words, what we're going to do is we're going to take our product of our means and set it equal to the product of our extremes and check, are they the same number? Because if they are, then yes, we do have a true proportion. Let's take a look at these two examples here. So then the top proportion here, remember the question is, are they equal? So we really don't know that these are equal yet. What we're going to do is check to see, does the product of the means equal the product of the extremes? So I'm going to do 17 times 522. I'm going to do 58 times 153. So let's do our 17 times 522 first. When I do 17 times 522, we get 8,874. That was 17 times 522. Now do 58 times 153. So do the product of the means. So 58 times 153, it gives us a number, 8,874. So there we have it. Are the products equal? Yes. And because the products are equal, is this a true proportion? Yes. That top one is a true proportion. Let's do the same thing for the bottom proportion. Find the product of our means, of our extremes, and set it equal to the product of our means. If they are the same, then yes, we've got ourselves a true proportion. So I'm going to do first 1.23 times 10.12, and I get 12.4476. Now, the question is it going to be equal to the product of the means? So that's 4.56 times 2.87. I get 13.08 7, 2. Those are not the same number, which means, is this a true proportion? No. Those ratios are actually not equal to each other, which means this is not a true proportion. So we've come to the end of our 7.1 lesson. If you do have any questions over this lesson or the assignment 7.1 worksheet, please do not hesitate to email me. With that, be good and do good.